Hey guys, welcome back to the Geography Academy. Remember, this video is just a small part of a much larger course that's available below if you just follow the links and instructions. This is section 3. This focuses on seismic hazards, including tsunamis and associated case studies. So we're talking about earthquakes. We have the general anatomy then of an earthquake. We're going to see the area where two tectonic plates are sliding past each other. They get trapped and friction is built up then. So there's tension building up and this is released. The place that is released is the focus. So seismic waves start to move out from there. They can be at various different depths depending on the type of tectonic plate. And we know that the closer to the focus is to the surface, the more intense that those seismic waves will be. The epicenter is often referred to when we're talking about reports on the news or case studies on earthquakes, and that is the point that is directly above the focus. So this area then is often the strongest in the shaking as the seismic waves then release and spread out from that point. The fault line then can come in different ways depending on which way the tectonic plates are moving. If they're pulling apart, like in a divergent or constructive plate boundary, this could actually cause a normal fault. A pushing together or compression, then on a destructive and convergent plate boundary is a reverse fault, and then a horizontal movement, like we can see here in the San Andreas fault, will be a strike slip fault. So different faults in different plate boundaries. Now, in the previous section, we talked about tectonic plates and their different movements. So seismic activity are present in all of the ones mentioned. We can see that there are different seismic waves, primary P waves, secondary S waves, and surface waves, which break down into Love and Rayleigh waves. So the P waves then travel the fastest through compression, and they can move through solids and liquids. The secondary waves are slower, but they can move through solids only and cause intense shaking. The surface waves then, the Love and the Rayleigh wave, travel along the Earth's surface, causing most destruction. So we can see here how it disrupts the top a lot more and will change the settings there quite a bit. So this causes then most damage in physical property. Now, from the seismic waves, that's one major hazard, a direct hazard. The other one is the tsunamis. This is a reaction to the same movement. So if we think about a destructive plate boundary, and we're in a fault line. Now, what's happening is as there is the uh, the sudden change, then we see because of that. So if we, yeah, here's a good example. So we've got the subduction zone that we mentioned in the last one on a destructive plate boundary. And what's happening is the plate is subducting under this one. It's pulling back this one as well, creating high tension in the Benioff zone as well. There's a release of the tension then suddenly, and because of that, the constructive, or not the constructive, the continental plate is going to move forward, and this is going to cause a large earthquake coming out from the Benioff zone. But as it does that, it moves position from here to here. So that little difference in position that's just here, the way it moves forward, obviously on a tectonic scale, this is enormous, right? So this is hundreds, thousands of kilometers long, and suddenly it just juts up. So this area here specifically then is going to see a rise in water directly above that, so it displaces the water. And that's how we see earthquakes coming, or tsunamis coming after earthquakes. So the earthquake is moving through the ground, reaches the area, that's where the people are living, and that's going to hit the area first and attack the buildings there. The tectonic plate then has shoved up here and has displaced that same amount of water above. So now a wave this size is starting to go towards the shoreline. Obviously not to scale. All right. So we have different hazards then, rock slides and landslides and rock falls, because of the sudden shaking of the ground decreases the strength internally and we see mass movements occurring. Liquefaction can also happen because there is suddenly a mixing of the sediment, and this causes a separation between it and the soil around it. This creates a really unstable kind of texture, which the houses and other things that cause pressure on the soil will potentially fall into. We also see the potential for fires as well. We can think about gas pipelines. In a lot of previous earthquakes, This has been known to happen and create huge extra additional hazards during a period of destruction where the fire services and the emergency services would find it hard to combat the fire as well. Flooding can occur as well because we can destroy levees or walls and areas that hold back huge amounts of water. And we can also get then the additional of glacier lakes as well, which we'll talk about soon. The disease spreading and humanitarian crisis is always an issue. After these disasters, if you're going to have a large scale disaster, this can lead to then the outbreak of cholera, for example, if there is a kind of contamination of the water source. Glacier Lake outburst flood then happens because we can see landslides, rock, snow, anything else coming into the Glacier Lake, which is stopped above an area here, and it will have a little bit of a lip here that holds back the water. Now, if the debris like the landslide, avalanche, calving of a glacier, for example, comes into this water, you can then increase the size and send a wave that will go over the top and down the valley. So this can be a very instantaneous flood, and going down a narrow valley aims usually down towards a settlement. The spatial distribution of earthquakes are going to be found on all tectonic plate boundaries as mentioned before.